All right, 5.5, polynomial and rational inequalities. So let's just get into it. Kind of obvious, we want to solve polynomial rational inequalities. So this would be a polynomial inequality. Now they're saying by graphing, there's two different methods, but we just want to solve this. Now the answer, just so you understand, will involve intervals. So we're going to draw the number line eventually and chop up the number line. We can tell immediately where it's going to be 0 at -4 and at 3. As a matter of fact, that's just one of the things we do, is we find zeros very quickly. You've been doing that, ever since you've been setting things equal to 0, where you had factored side, 0 side. So we know when it's 0, but when is it positive? That's the question. All right, so like I said, just using graphing techniques from earlier sections, we know when it's 0. We also know that there is the graph will cross at the degree 1. Let me write the inequality again. It was x plus 4 to the first power and x minus 3 squared. All right. So we know that there's this is going to behave like x cubed, and that it's going to leave the box in these quadrants. At the 0 with multiplicity 1, it's going to cross. And at the 0 with multiplicity 2, it's going to touch. And why was that important? Well, I want to look here as though this is a number line. And I want to ask myself, so when is it above the x-axis? When is it in quadrant 1 or 2? All right, so between this point and this point is where we had -4, and this point where you have 3. Between those points, it is positive. And it briefly is 0, and then it's positive again. So I have these two intervals, specifically from -4 to 3, and then from 3 to infinity, where the graph is going to be positive. By the way, the only part where it's negative is when x is less than -4. It's just that one part where it's negative. So if they had asked the question with a less than, we would be looking for negative numbers, but they had said greater than. All right. Now they say you can also do this algebraically, and that's definitely true. You can do it algebraically. I just don't like the way the author does it. We're trying to find, I'll show you where I object to it. This is greater than 0. Double check, yeah. That problem. All right. Well, so the other says, all right, let's set it equal to 0. I'm okay with that. And then by setting it equal to 0, we're going to discover when it's 0. So understand, they set it equal to 0, they factored it, set this equal to 0, got 0, set this equal to 0, got -1, tried to set this equal to 0, and it turns out it had no real solutions. So at this point, I know when it's 0. It's 0 at -1, and it's 0 at 0. So I know when it's 0. But remember, the original problem was asking me, when is it greater than 0? Well, once again, I know it's going to touch at 0 because this was degree 2, and it's going to cross at -1. And how is it going to leave the box? Well, it's going to leave the box the way x to the 5 leave the box in quadrants 1 and 1 and quadrant 3. So where is it positive? Kind of the same old story, but the author went through a little more than, did draw the number line, didn't really do the signs on the number line, but essentially got that. And yeah, gave us the intervals that we kind of expected on this one. The only thing I don't really like is this whole table here. I'm of the mind, if you know when it's 0, draw those points and then do the signs right there on that grid. But you can't argue with what the other has there. All right, so this would be a good one to do quickly, because if you just spend too much time on these, the whole thing gets kind of muddy. All right, I'm going to plot -3. I'm going to plot 1, and I'm going to plot 3. Now, I didn't determine when this thing is 0. Well, I did. It's 0 at when the numerator is 0. It's actually undefined when the denominator is 0, and I definitely want to distinguish between those. All right. Let's try a test point like 6. It's in this interval from 3 to infinity. And if I put 6 in this problem, look at the factored version. Every factor is positive. Positive, positive, positive. So I know this is positive. It's going to change signs. It's not an opinion. I know it's going to change signs because this was degree 1. If it had been degree 2 or 4, something even, it wouldn't change signs at that point. And I should be talking about this one. X minus 3 is where that 3 came from, right? Where x minus 3 equaling 0 is where that 3 came from. And it's degree 1, so a sign change. This is degree 1, so another sign change. Odd degree. This is degree 1, so another sign change. And I'm looking for when it's greater than or equal to 0. So where is it greater than or equal to 0? Where it's positive and where it's 0. Where it's positive. Now, notice I'm leaving the open circle where it's undefined, because I don't want where it's undefined. I want where it's positive or 0. So the interval notation. -infinity 1, union 3, infinity. And we're done. That's it. That's what we wanted to do. Well, they went through a lot more elaborate process, but, I don't blame the author for sometimes over-explaining something. They said, well, what if we graph the whole thing? And then you looked, when is it greater than 0? When is it greater than 0? And, maybe when it's less than 0. And they got the same answer we got. But my point there is, we can do these algebraically, or we can do them not algebraically, graphically. But algebraically, give it a chance. So I like to call it, what we need is, factored side, 0 side. And 2 is not 0. So what's really important here is, when I say greater than 0, there's a name for that, positive. When I say less than 0, there's a name for that, negative. But when I say greater than 2, there's not a name for that. I need this to be 0. So we subtract the 2, get a common denominator, add it all together. Looks like these will cancel. 5x minus 4x is just x. 6 plus 6 minus 2 is 4. So we do all the work and we get this. Put parentheses around there. And we have what I call factored side, 0 side. So I could have tried to get factored side 2 side here, but factored side 2 is not the same as factored side 0. All right. So I know where this thing's going to change signs. At -4, I should say change signs maybe, and at -1. Those are my only what we're going to call critical values. And now remember, this was a 0 and it was degree 1, and this one is undefined and it's degree 2. Those are important. All right, put a big number in. I like to start way at the far right. Put a number like 6 in here. I get positive divided by positive. Positive divided by positive is positive. What's it going to do at this degree 2 undefined spot? It's going to not change signs. It's going to stay positive. And then at this degree 1, it's going to change signs. So, when is it greater than or equal to 0? That last question is almost a childish question. Well, greater than 0 means when it's positive or 0. And it's positive there. Remember, it's undefined at -1, so that can't be part of the answer. But I've got two intervals, -4, -1, union, -1, infinity is going to be my answer to this question. So they went through a little bit more analysis than I think is recommended, but we got the result. Let me just double check that I didn't have any typos in there yet. We got the expected result. So yeah, I'm intentionally not making these tables. I think it's just better to just draw it. And the author did. The author drew it. And then putting your test points, knowing it's going to not change signs because of the x plus 1 squared was involved. The square, the 2, suggests it's not going to change signs. And it's going to change signs here because of the x minus 4 to the 1. Yeah. Gives us the same idea of positive, positive, negative, but in just a little less real estate on the page. So I don't really know if I like that table. But that's it. That is inequalities. Don't forget, you have multiple ways to do it now. The way I showed you with a number line, the way the book showed you with this table, and of course, a two-dimensional graph. If you like doing it that way, it also tells you where it's positive above the x-axis and where it's negative. But all right, that is section 5.5. Now, if you're watching this video, 5.6 and 5.7, I kind of approached a little differently with a different style video. So you might not see a video directly on 5.6 and 7, but you'll see my take on those concepts, which are basically what I call factoring on steroids. So come back for that video, but this is 5.5.